So now that we finish with the artificial beings, we're going to move into the birth of the AI. So get ready for talking about Turing, about this imitation game, to this very important conference that you will hear everywhere, that is the Diamond Conference, and then to move to expert models like ELIZA that appear in the Big Bang Theory and other type of shows. So let's start. Now we are going to start talking about the birth of AI. And if you remember, this happened in the 20th century with this person, Alan Turing, that in addition to uh, lay the foundations for computers, yeah, the computer foundations, by introducing this Turing machine that rather than a machine was a concept. So in 1936, he created this theoretical model of a machine that instead of solving one problem, it was a universal machine that it will be programmable to solve multiple problems. So different from the Enigma, the Colosseum, that they were just looking from de-encrypt to the decipher some codes. This was going to do multiple problems, and this was very important to lay the foundations of computers. And in addition to that, in 1950, so 4 years before his death, he introduced the Turing test. And the before class, if you have the time, you could have watched this video about TED Education, like about the imitation game. Yeah, the idea is, if you remember the movie, the imitation game, the idea is that Turing introduced these tests. And why is the imitation game? Because it's a test that when you, for example, are talking to ChatGPT and you say like, okay, this sounds like human sometimes, or sometimes like, okay, this is clearly a machine. These sentences sounds like a robot. They sounds too formal. Nobody's going to talk like that. So he developed a way to evaluate if a machine has the ability to exhibit intelligent behavior that is impossible to distinguish from humans. Yeah, and if you want to know more about that, you can watch this video that they cover it in a lot of more of detail. Okay, so remember Alan Turing. We can put it like he is one of the person that start this field of the artificial intelligence. Okay, so independent of the sort that you are looking for, you will hear that one of the more important events that start this early research in artificial intelligence was this Dartmouth workshop. That instead of being 2 or 3 days, it was actually 8 weeks in which scientists from different fields they got together to outline the goals of this machine intelligence field, and in addition to that, they start discussing and having ideas. And it was not people only from one field. It was not only mathematician or computer scientists. It was people from psychology, from neuroscience, from different social science, even linguistics were involved into that. And why linguistics? So imagine ChatGPT, how important it is to understand the rules of language to be able to create something like ChatGPT. Um, okay, so remember, it's considered this Darman workshop is considered the birth of AI as a field because it outlined the goals for machine intelligence. And here I show you some of the founders of this of AI, yeah, that attend to that conference. And between them, I highlighted three of them. One of them it was John McCartney that coined the term artificial intelligence. Another one is Marvin Minsky, that we will talk about that in a few slides, and also Herbert Simon, that we will talk in the following slide. I also told you that there was different people in this conference that come from different fields. Some of them were, of course, computer scientists, mathematicians, but there were many scientists studying, for example, the brain. Yeah, so studying intelligence from different perspectives. So like neuroscience, psychology, philosophy, and of course, linguistic, like I said before. All of them were very important, and we will see some of the applications that they start develop. So let's start. So we're going to continue talking about the history of AI, but in this case, we're going to talk about one of the early programs. And one of the early programs was this logic theories that it was developed in 1956 by these two guys. These two scientists, if you remember, we talked in the previous slide about Herbert Simon and in the Derman workshop, and here Newell was also the other scientist. And maybe if you study math, you have heard about the Principia Mathematica. It's a seminal work on mathematical logic, and it has a theorem. And what is important of this book is that this book, uh, to solve the theorems, you need to think, and it was considered that only humans will be able to develop reasoning to solve those type of problems. And what they did is use a simple set of rules, some basic assumptions, yeah. So inference rules, and the idea that they were trying that the program was going to prove these theorems, and they use a heuristic search method, and the result, the output, is that the program was going to print the logical step leading to the solution. And it was able to solve 38 from the 52 theorems, from the 52 problems. So this was a foundation milestone in the history of AI. Why? Because it shows that these machines were able to solve problems, yeah, that it was considered only that only humans can do this kind of things. So it was very important, and it's considered, as I said before, it was considered a milestone in this area. And just to remind you, so key information here, that what is this logic theories? It was regarded as one of the first artificial intelligence program. It was just proving mathematical theorems. So it was solving mathematical problems by mimic human reasoning. And who created? I told you Newell and Simon. Okay, so first programs that were created, it was these logic theories. So now we're going to talk about the growth and challenges that took place between the 1960s to the 1980s, and we're going to focus in this case about the expert programs. So what is an expert program? An expert program where a group of pioneer system decides to simulate the human expertise in a scientific domain. So we're going to talk about three examples: Dendrol, Messick, and ELIZA. The purpose of Dendrol was used for scientific reasoning, and I will show you that giving an input, it will try to predict the molecular structure of a chemical compound. Mycin is a program, a system that will help assist doctors for medical diagnosis and therapy. And finally, ELIZA, that is a natural language processing that mimic conversations using AI. And to some degree, it works as a psychotherapist. Yeah, so I will show you a video of what it does. So what makes this program an expert program? So these kind of programs are used with this branching structure. Yeah, so if something happened, then do this. And then if this happened, do this. Yeah, so for example, if somebody is healthy, then send them home. Yeah, if somebody's feeling well, the person can go home. If this person is unhealthy, yeah, ask them more questions. So if the person is unhealthy, is sick, ask them if he has a runny nose. And then you can keep asking and asking more questions. So those type of things, yeah, are called rule-based reasoning. So you give an algorithm and a knowledge of an expert that it can create this type of rules based on the expert reasoning and expert knowledge. Yeah. So they rely on a predefined rules, and the algorithm make the expert decision make. So another reason why they are expert programs, in addition to rule-based reasoning, is interactivity. And here, as you can see in this diagram, we have an expert in the field, medicine, chemistry, psychotherapy, anything, a scientist, that will communicate his knowledge to a software engineer, and the software engineer is going to create a knowledge base. And this will end up with an inference engine that can be used, yeah, by a user, yeah, that it will have an interface, so the user will just communicate, type the questions, and for that reason, interactivity is another characteristic, another feature of programs. So remember, many of this system could interact with users and provide solutions or explanation for their decisions. And what it was the good thing about this impact, the impact on AIs, yeah, of these expert programs. So first, these programs lay the groundwork for modern AI systems. So for example, they show the utility of AI and specialized tasks. In addition to that, they inspired the development of modern systems. So now we have virtual assistants, that is not stick methods. All those things were inspiring on these expert systems. Finally, it introduced concepts like rule-based reasoning, expert systems, as well as natural language interaction this is very important right now. Now, let's go and start talking about some of those expert systems, not in a lot of detail, but just general ideas. So let's start with Eliza. Although there is more programs, I wanted to show you one that is called Eliza, yeah? And this Eliza, I want to ask you this question before I play this video. Does Eliza remind you of another program? You know, Eliza, if you have watched Big Bang Theory, they talk about that. And if I cannot play this video, you can find it here. Okay, so let's play that video and you can hear about the history of Eliza, that I find that is more entertaining than me showing you this. So let's start.
Does it understand what it's doing in the sense that we do? It's easy to leap to false conclusions, as Professor Weizenbaum discovered when he created ELIZA. ELIZA is a computer program that anyone can converse with via the keyboard, and it'll reply on the screen. We've added human speech to make the conversation more clear.
Men are all alike.
In what way?
They're always bugging us about something or other.
Can you think of a specific example?
Well, my boyfriend made me come here.
Your boyfriend made you come here.
He says I'm depressed much of the time.
I'm sorry to hear that you're depressed.
It's true. I am unhappy.
Do you think coming here will help you not to be unhappy?
The computer's replies seem very understanding, but this program is merely triggered by certain phrases to come out with stock responses. Nevertheless, Weizenbaum's secretary fell under the spell of the machine.
And I asked her to my office and sat her down at the keyboard, and then she began to type. And of course, I looked over her shoulder to make sure that everything was operating properly. After 2 or 3 interchanges with the machine, she turned to me and she said, "Would you mind leaving the room, please?"
And yet she knew, as Weizenbaum did, that Eliza didn't understand a single word that was being typed into it.
You're like my father in some ways. You don't argue with me.
Why do you think I don't argue with you?
You're afraid of me.
Okay, so I wanted to show you this video about Eliza, and I don't know if it reminds you of any any new program of AI, maybe to ChatGPT a little bit when you start just having a chat box, and you type things and it can reply something. So it mimic again the interaction that we have with humans.
Does it
Okay, so now I just wanted to show you this example of this weird program that it used to sound like a therapist, yeah? And I will show you that they try to do the same thing with doctors. The idea that in the past they were thinking we're going to replace doctors because AI is we're going to replace it using this type of program. And so far, and right now it's in the trend, as I have said before, the idea might be that uh, humans are very smart at some task and AI is very smart at another one, so they can complement each other. But at this point, Eliza is just a great step in trying to understand, or a precursor of these modern day chatbots. And maybe you have used chatbots before when you need interact. You have a question with the bank, with a textbook, with so many things that you don't know, and you need a rapid way to answer the question. Chatbots are the best. Yeah, ChatGPT is an example of that. And so Eliza was created between 1964 and 1966, the development of this program, and is an early version of this natural language processing program, so NLP. And here I show you a picture of what is NLP. Is a combination between computer science and linguistic, yeah, using AI. So here in the middle you find the NLP, because the idea is to create these conversations, yeah, that simulate human conversations, but are based just on artificial intelligence. And there is a big field, yeah. This NLP became a big field of artificial intelligence and allow computers to understand, interpret, and generate human language. So this is a very important field that is going to continue growing, and this is just one of the early stages. So I'm going to talk a little bit more about these natural language processing programs. Why? Because they are very important, and we are going to talk more about that later. So if you have used ChatGPT, what you're using is these NLPs. If you use Siri or you are using Google Assistant, any of those are just using NLPs. I just have my phone here and I say Siri, and it already activates himself. But anyway, so here I love this diagram, because in the same way that I say Siri, and my cell phone right away is activating something. What I am trying to say in orange is a word, but what the software, yeah, the NLP is listening is this. So the NLP is going to allow, yeah, my cell phone, the different programs to be able to communicate, yeah, and the artificial intelligence, yeah, program is going to have an answer that I will not understand. It's just one and zeros, and this is going to turn into hello, yeah, and so that the NLPs are fundamental for us to interact with these programs, yeah, and so they are designed to process and analyze large amount of language data, and later we will talk about why, how, for example, ChatGPT work, and how it's able to bridge the gap between human communication and computer understanding. So we will talk about different type of chat bots, yeah, and how they use NLPs and how they are able to generate human-like responses. So here we will talk about that this T from Chat GPT, the transformer, it was the game changer for this is the transformer was these programs were the game changer for this technology, and we will talk about why later. Okay, how this started evolving, but we will do it in another class. Right now, I just want that you start getting this concept. Yeah, so one of the first programs was ELIZA, and that it was like a psychologist, and it was an early version of an NLP that simulate this human conversation. And this early version, it allows that it looks it doesn't look very good right now. Actually, it was a precursor for something that like ChatGPT and all the chatbots that we use now that have improved significantly. So now we're going to talk about another program, Expert System, that took place still in the between the 60s and the 80s, and it was very important for the growth that showed the growth and the challenge of AIs or artificial intelligence. And here you can see a diagram that I create with artificial intelligence, and if you see, it has a lot of details. So I'm going to explain it. So Dendril was a program that the input, as we said before, it was mass spectrometry. So the idea is it was going to help chemists, as I said before, to determine the chemical structure. So to do that, it has a simple set of rules, as you can see here. So chemical, physical, and chemical rules that they were going to help to develop that it will chemistry, because it was going to assist chemists in to find the chemical structure. And so in this stage, there was a lot of activism and early success by the logic theorists, by other programs, you know. And in this case, this expert system, one of the first expert systems used with AI, and as I said to you before, it was designed to assist chemists. And as I show you this diagram, remember, it get mass spectrometry data. Yeah, so the weights, the chemical weights, and and they also gave basic simple rules. And in that way, the idea it was that it was going to help to analyze a complex task that take chemists a long time, that is to determine the molecular structures. But now we're going to continue talking about another expert system. And in this case, it was an expert system that helped to diagnose disease. So here in this diagram, you can see another attempt of artificial intelligence to explain to create a diagram, and here you see that it has a typo but it looks very pretty. So same thing that happened with this expert system, and in theory it should work, but it is still more. It still need more power, and it has some problems. So the idea here is that you will have patient symptoms. So for example, somebody has runny nose, yeah. Somebody or another symptom, it will be a sore throat, and you can say like, okay, the system will say if you have sore throat and if you have runny nose, then as if the patient has been in contact with somebody that has been sick with a cold, and say like yes, yeah. So, and if not, you can it will ask more questions. So the idea is that you have these symptoms that it will be the input. You have the expertise of a doctor, of a medical doctor, a series of rules that it will help to create an output that it will be the diagnosis and treatments of diseases. Of course, this was not created for all the diseases; it was for a specific group of diseases. However, although it was a great attempt, and it shows that it, as usually, these if and then expertise models were very good at a specific tasks. For example, with novel and uncertain diagnosis, they were not very good at doing that. Yeah. So in novel scenarios, in something that they don't know how to solve it. And in addition to that, there were some ethical considerations that the software was not ready to answer. So just to remind you. So again, we are in this stage that there was a lot of optimism and early success. And as an example of that, it was developed in Stanford, in the University of Stanford, this expertise model. That the idea is that it was going to assist doctors, and to some degree, some of them they were saying that it was going to replace doctors in the future. So, and again, this was one of the first expert system oriented to medicine, and the function was to assist a physician, and the idea was that you are going to input, the input will be some symptoms, and the output will be the diagnosis and treatment of some diseases. Uh, so we talk about artificial beings in the beginning, and we went from myth uh, to the philosophical interpretations to the first application of the automata, these self-operating machines. And then we move into the 20th century, and we start talking about Turing, and we talk about the Darwin Conference that set the outlines of artificial intelligence. And then we start moving into the first expert programs uh, like ELIZA. Now we're going to move into the winter of artificial intelligence.